Welcome back to Business Mathematics 2 MA 1203. We will still going to discuss the method of finding the approximation of definite integral. So in this session, we will discuss about the error in approximation. We will discuss the error in approximation for the trapezoidal rule and for the Simpsons rule. Okay, so the error in trapezoidal rule, let's say they want to find the maximum error of integration using trapezoidal rule, dividing integral a to b into n subintervals. And then the maximum error, the error is given by this, an equals b minus a cubed 12n squared times m. Okay ya, the error is given by this. This is not maximum error ya. The error is given by this. The error is given. Oh sorry, this is the maximum error ya. This is the maximum error. Okay, where with m is the maximum of f double prime x. This is the second derivative of f on a comma b. Let's say we, in the case of approximation of 0, 1 x squared dx using two subintervals, the maximum error is given by E2, the absolute value of E2 is 1 minus 0 squared divided by 12 times n subinterval is 2 subinterval squared times m. What is m? M is the maximum of the absolute value of f prime x. So m is the maximum of f prime x, the absolute value of f prime x. But f prime x, if I have x squared, the f prime x is 2, and the absolute value of 2 is 2 on interval 0 and 1. Okay, in general, m the derivative of f, the second derivative of f with respect to x depends on x, yeah. But in this one, in this case, this is just a constant. So the maximum is this constant. Okay, so we will obtain m is 2. Okay, so E2, the maximum error is given by 1 over 24. Why? Because this is, okay, times 2 and 0.02. So this means the value of integral is 0.375 plus minus. Oh, I'm sorry, this is not 0.02. I think this is 0.04167. Sorry, I'm so sorry. So this is 0.04167. So the value of integral is approximately 0.375. What is this? This is the approximation. So this is the approximation plus minus the error. This is the error. So the value of integral should be between 0.375 minus this until 0.375 plus this. So between this and this. So the approximate of integral using two subinterval is between this and this. Okay, try to find the error of approximation for the case n equals 3 and for the case n equals 4. Okay, and then look at this example. In this case, we are going to use the same trapezoidal rule, but the question is find the number of subintervals such that the maximum error is less than 10 to the power of minus 5. That is 0.00001. Okay, so here we want to find the positive integer n such that the maximum error is less than 0.0001. So previously we have found that the maximum of f double prime x, the absolute value in 0, 1 is 2. So an should be this, and the formula is given by this. I can substitute b is 1, a is 0. So I have this one less than this one. So I can multiply by n squared. So I have n squared should be greater than this one. Okay, and because n should be positive, n should be greater than the square root of this. And the square root of this is 129.09. Don't forget, n should be an integer. So an integer after 129. So it should be 130. So at least you have to use 130 subinterval so that your maximum error is less than 0.00001. Okay, yeah. So why do I have this in boldface? Because don't forget, if I have n squared greater than this, how do I solve this? Bring it to the right hand side. So like n squared greater than 4. So I have n squared minus 4 greater than 0. So I can factor this out, n plus 2, n minus 2. So the answer is n greater than 2 or n less than minus 2. But it should be positive. So we will just take n is greater than this. Okay, yeah? Okay. And then error for Simpson's rule. For the general Simpson's rule, dividing interval AB into n subinterval with equal length, the maximum error is given by this, b minus a to the power of 5 divided by 180 n to the power of 4 times m, when nm is the maximum of the fourth derivative of f x on interval a and b. So in example, we will want to find the error of approximation of integral 1 to of 1 over x dx using two subinterval. So the maximum error is given by this. 2 minus 1, b is 2, and a is 1, and n should be two subinterval. So 2 to the power of 4, 180 times m. But we have to find the m. What is m? M is the maximum of f to the power of fourth derivative of f at x. So the fourth derivative of f at x is 24 over x to the power of 5. And the absolute value of this is just this. Why? Because x is from interval 1 until 2. So it should be always positive when x is substituted with a number between 1 and 2. Okay, yeah? And then, how do I find the maximum of this on this interval? Don't forget, we have to find the endpoints, 1 and 2, stationary point. Okay, there are no stationary point. You can check. There are no stationary point on interval 1, 2, and singular point, and there are no singular point also in this interval. So we can just check on the endpoints. The endpoints is 1 and 2. At x equals 1, the value is 24, and x equals 2, the value is 0.75. So which one is the maximum? The maximum should be 24. So this should be 24. Don't forget, you have to use this kind of procedure. To find the maximum, you have to find this one. Okay. Hence, E2 approximation, the error in the approximation with using two subinterval with equal length is just substitute m equals 24, substitute this, and you have this divided by this. This is 0.00833. This means the error is this, yeah. Okay, the approximation plus minus the error. Okay, yeah. So this is the range of the value of the integral. Okay, try for n equals, no, sorry, not n equals 3. Because when we are going Simpson's rule, we have to use even subinterval. So maybe you can check 4 and 8 maybe. Okay, yeah, try. And last one, this is the application of numerical integration, that is area of irregular form and present value of an income stream. So find the area of the pool if the length is measured every 1.5 meter. So from this to this is 1.5, 1.5, 1.5, 1.5, 1.5. So x0 should be 0, x1 should be 0 plus 1.5, x2 should be 0 plus 1.5 plus 1.5, that is 3, x3 should be 4.5, and so on. So don't forget, this is we just want to find the area. this area. Okay, yeah. So what is the height here is 0. The height at 1.5, this at x equals 1.5, the height is 9. At x equals 1.5 plus 1.5, at x equals 3, the height is 10, and I can get this and so on. Okay, so I have x and y, this x and the height is y, x and the height is y, x and the height is y, x and the height is y. So how do I find the area? The area, very good. The area is given by a half times the height. The height is always 1.5. Don't forget the pattern. 1 times 0 plus 2 times this 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 plus 1 times this. So you have this one equals this one equals this one. So you have 160. Okay, yeah? 1, 2, 3, 4, 5, 6, 7, 8, 9. Try using the Simpsons rule. You cannot. Why? Because you have 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 subintervals, so you cannot use Simpson's rule. You can use Simpson's rule if the subinterval is even. Okay, here we cannot find the error also. Why? Because I don't know the f also. Yeah, because we want to find the derivative of f, but here we don't have the f, so we cannot do it. Okay, what about the present value? A manager is selling a franchise which will last for 6 years. From the previous data, the income stream ft in $1,000 after 3 years is as follows. Okay, yeah, this is the income stream for every year. If the interest rate is 5% PA compounded continuously for 6 years, okay, yeah, find the reasonable present value. And the present value is given by this formula. So if I look at let GT equals FT times e to the power of minus 0.005t. So this is t years is 0, 1, 2, 3, 4, 5, 6. Okay, yeah, 5, 6. So, and what is the height? The height is G0. G0. F0 times e to the power of this. F0 is 510 times e to the power of this times 0. So you have this one. What about G1? G1. F1 580 times e to the power of minus 0.05 times 1. So I have 551.7. And you can get this and so on. And in this form, you can try to compute this using the trapezoid rule, and you can try to use using the Simpsons rule. Can you look at the error of the approximation? Yeah, of course not. Of course not, because I don't have the f. I just know f at a certain value. Don't forget, to find the error, I have to find the derivative of this, but you don't have the f, so you don't have the derivative. Okay, that's all for the error of approximation of numerical integration and the application. Thank you very much.